this is Matt, and welcome to my shop. So, I mentioned this machine a while back, and I've shown a little bit of it, but I haven't got as much posted as I've really wanted to, and most of that just, I haven't had the time to get to doing all the editing that I've wanted to. So I've got a bunch of videos that I've shot regarding this machine that I'm going to try and get put out now. So basically at this point, I've got this up. It is running at this point. It's usable. I've been using it. There's still a few little refinements that I need to do over time, but I've got it where I need it to be at this point. So the next several videos that I'm going to be posting have to do with taking it from where you saw it when I first introduced it to this point now, and what it took to get it there. So when I first got this, it was set up, it was for 3-phase power. It originally was a high voltage machine. It was like 550 volts. The guy I bought it from, he had the motors rewound and some of them replaced that brought it down to the 220 that I have here in the shop. But I don't have 3-phase power. So part of what needed to be done is I needed to set this up so I could run it on single-phase power, which involves using inverters or VFD drives. The other thing that I did when I got it, it did not have anything for DRO. It was just the manual controls with the dials. So I've added the DRO system to it. That is complete now, except for one auxiliary one that I'm going to put on the quill up here. There is one on the knee, however, so I do have Z-axis on it. So like I said, the next several videos I'm going to go through that process. So we've taken this machine from the original controls with the electromechanical, the relays that activate the various motors up here and down on the bottom down here, to the current system now, which allows me to run on straight 220 power. It's modern. We've got a pair of inverters up here and another one that is down in this case. I'll see if I can get a photo for that. I don't want to open it right now. Besides letting me run on 220 power, they also introduced the capability of some new features, because these are programmable. I'll go into more detail on that on the videos, but they can do more than just run the motors. Basically it has to do with logic and how things turn on and off, various safety features and wind-up speed, things like that. So, as I said, next couple of videos we're going to detail the process of this and the DRO installation. And this video will be the process of preparing this box to install the inverters into it. All the wiring, cutting the holes for the fans, the electrical, all that. So I believe I just lucked out on something here. Originally I was planning on putting all 3 inverters up here in the upper control box, which was going to be extremely crowded, really not within specification for these. They're supposed to have a good bit of ventilation around them, like a couple inches to each side. And I was going to get around that by putting a powerful ventilation in on the top and bottom and drawing air through the top vents, and where the side vents would be covered, I was going to leave these open, which would allow air to get sucked in through there, and I'm sure it would have been sufficient. But, you know, I'm going to use a 120 millimeter power fan up here. And I 3D printed this little riser because the units come up to within 2.5 inches of the top, so the fan would stick above. So I made this little piece, which I was going to slot and mount in that way, so the fan would have an opening further up. cut this out on the inside, and it would allow the full volume to go through. And with a 2.5-inch channel along the top here, it would draw the air out from the top of them. And I'd also have a space on the bottom of about 2 inches, drill holes on the bottom. I'm probably still going to do that, but I think at this point I might be doing just 2 units in here and giving the airspace around them that they should have. Because here's the thing, I didn't think there'd be enough room in the lower cabinet to fit one of these units, but take a look at this. That actually fits in there with the door closed, because the door bows out a little bit, and I didn't think it would be enough of a bow to clear, but apparently it is. I can close that door fully closed, and that sits inside there. Now granted, there isn't a vent in here, but with this much cast iron, I really don't think it's going to overheat in there. It should dissipate the heat that comes out of that. It doesn't really generate a lot of heat. And this one's just going to run the knee motor and the coolant pump, so I think the dissipation should be fine. And I think I'm going to go with it. And we'll just do 2 up here with plenty of ventilation on it. These are the ones that actually draw the power. I'm going to have one that'll do the horizontal spindle, which is the big motor, and the vertical one, which is 3 horsepower. So here's the inverter for the lower cabinet. It's all mounted in. And I cut this bracket that was originally in here that held the breaker and all the relays on it. I'm going to be putting the, well, not breaker, it's the cutoff switch with the fuses. So I'm going to be reinstalling that. So that'll be going up on the top. And my next steps in here is I have to wire in this switch. The switch is going to be to engage the pump for the coolant. I'm putting it internal here because where I'm running them both that and the knee motor on the same inverter, you don't want to be switching a second motor on and off while the inverter is actually running the motors. Everything needs to be stopped before you switch it. So I figured I'd put it in the cabinet. The disconnect has to be shut before you can open this door anyways. So everything would be shut down whenever I go to turn that switch on or off, having it in here. Then there's no chance of an accident where I switch it with it powered on. So I've got the inside stripped out, and this was pretty easy because it's pretty well all mounted on a board here. I just had to disconnect the wires that go to the board, and the rest pulled out as a whole assembly. So the fan, I don't think I'm going to use the riser box I made, where I'm only doing 2 inverters in there. There's plenty of airspace around them now. So I'm just going to put this on the end. I've got it as high as I can get it in the back corner. And I'm going to put it on the outside, make it less restrictive inside. So now I'm just getting stuff marked out, getting ready to cut the main opening. I've already drilled the holes for the mounting screws. So there's our markings for the main cutout hole, and the mount holes are already on there. Now I'm going to cut just a little bit outside of that because all I did was just trace the inside of the circle. And I already know that this edge here is about 2 millimeter wide between the outer edge and the inside. So I'll probably just divide that right in between the edge there. And it doesn't have to be perfect. We just need a nice opening there and not have a gap on the outside. Also down here, this is going to be cut out where an electrical box gets mounted. This one here. And this is just going to face down at the bottom. And this is to where I'm going to plug in the DRO. And actually probably have it that way. The DRO will plug in here, and I'll have one extra. to clean it up a little bit, but that should do it. So the fan came with 2 of these screens, and I don't need one on the inside. So I'm just going to mount this one on the outside once I do the final mounting here. I just got it laid in. And I'm going to use this other one for the intake. So we're going to have our box down here. Let me get that over there. Got the opening cut here. I got to pick up screws to mount this. And that'll be roughly about like that. And somewhere back here, I'm going to probably cut a hole like that and just put that on there. And I'll do just like I did up there. I'll use the fan to mark it out, trace it, and drill the outer holes. And we'll just do it down here. Fan won't be mounted there. We'll just bolt this screen up on there with some short screws and call it good. So that gives me good marking that I can cut it out on. Again, I'm just going to go just to the outside of that line, but inside of the square line. So on the last cut I ran 35 amps on this, and that seemed to do the job pretty well for this metal, thickness of the metal. So I think I'm going to do the same here. So I'm going to put a ground clamp right on here because it does have trouble getting through this paint. Pretty thick layer. I think I can get that started there. We'll give it a try. Now I'll grind it. got a rough cut. And I'll just finish this up with a die grinder with a wheel on it. I got a couple little jumps here where I stuck, but they may show, but no big deal, it's underneath. I think that should know it for what it is. So I don't have the screws here right now, but they'll just mount up like that. An electrical box, right about like that. I've hit these with a center punch beforehand. The circles are just approximate, so I know roughly where it is. So when I go in here with the bit, I'm actually hitting that little spot. Blow all the chips out of here before the inverter's in. So again, I got to get the screws to put them in, but that's where they're going. Now I've got the controls are out right now because I'm going to mount those. I'm going to get a longer cable for these, and I want to mount them on the outside where I can see them. Either that or cut a window in here and put a piece of plexiglass in there, or probably polycarbonate. And so I just, not so I can control it, I just want to be able to see the numbers there, because I do want to be able to see how much amperage I'm drawing, which is what I usually have these set to display. As far as the controls go, once this is all fully done, I'm not going to be using these to control them. They'll be controlled remotely using the connections that are inside. But this is where they're going to be. The inverters are going to be. This one is going to be for the overarm, and this one will be for the horizontal, which is 7.5 horsepower. So both these inverters are a little bit oversized for the application I'm using them for. It gives me a little bit of headroom. It enables me to start them easier. Because with the way this was set up, the motors originally, during startup, they worked in an overload situation where they actually were drawing more than the 7.5 horsepower for the horizontal or 3 horsepower for the vertical. Once it got up and running, you'd be within tolerance. But for the couple of seconds it takes to start, it would be an overload. So the smaller inverters, and I started with appropriately sized ones, and they struggled with it because they just couldn't bring it up to speed quick enough, especially where it's cold in the shop. These do it with no problem. I've got both of them timed out for a couple seconds startup, and they're doing fine. I don't think this would even fit in the Cincinnati, because I think the Cincinnati is 18 inches max, and that's right from the table to the spindle itself. By the time you get done with the tooling, it's even less. So in that respect, this home-built mini mill actually has a little more range on it height-wise. Of course, it's nowhere near as stable. It doesn't have the power or anything like that. But this is one reason that I want to keep this around, is because it can do some things that I can't do on the Cincinnati. The other thing is this thing can get much higher RPM, which I've mentioned before. So for really, real small detail stuff with fine bits, it definitely is better for that type of thing. And the rigidity is less of an issue with the small cutter, because you just don't have the cutting forces that you do with a large cutter. So I'm cutting for this circle here, and it doesn't have to be an exact, down to the thousandths or anything like that. I'm just going to eyeball this on here. It's just a cutout to pass some electrical connections through. This may move on me. It's very likely it's going to wiggle around. I don't have a way to secure this because of the size of it, so I'm going to be pretty much just trying to hold on to this thing as we go. I think that's going to put me pretty close to where I want. I'm starting real slow here because I don't know what this is going to do. Definitely wants to walk. Okay, so I'm going to pause here a minute. I'm going to see if I can rig something up with some web straps to try and hold this down, maybe get some blocking between the post and the front of the box to hold it stable. So I'm going to pause the camera for a bit and come back, and we'll give another try at this. Because I can tell right off, trying to do it just sitting here, I'm going to run into trouble. Okay, so I got one web strap on here, and this seems pretty good actually. I don't have any extra blocking in there, but I think this is going to be enough to do this. We're going to give it a try. You've probably never seen web straps being used on a mill, but anyone that knows me well knows I love these things, and I think you'll be surprised how well this works. actually broken the center out. Now I'm just getting the peripheral out. Get it to start to move here. Probably should have done that in one shot without stopping. Yeah, I should have gone right through in one shot. And we're through. Considering the way that this was held down, I'm very happy with this. This came out good. And you can see, I mean, the web strap, it's not ideal when you have better setups available, but if you can't reach with something like this to tie it down, it can be done, and it works. Okay, so now that we got our hole drilled, which would be this one right here, and this goes towards the front of the machine. This is where the connection is to the overarm, which would be the heads up there, and here's the electrical connection stuff that goes out. So that box sits right here. That would be that one hole, and the other one's going to be up here. So we've got our two inverters. They're going to be sitting in here like this. I don't have them mounted just yet because I still got some work I need to move around them, which is easier to do with them out. We have our cooling fan up in here. Let's see if you can see that down there. So that's 120 volt, 120 millimeter fan, AC. This is where the connection is to the bottom of the machine. We've got an intake down here, which I showed you before. The electrical box here, which we're going to use one of these outlets to power the fan. I could hardwire it internally, but I figured, well, if it burns out, it's easiest just to change it and unplug it, put another one in. And the other one is going to be for the DRO. Anyways, so this new hole, what it's for, you see I've got my control panels are out of here. And the reason being is because, well, these knobs stick up further than I can close the door, for one thing. For two, I want them visible. Because these display, well, you can set it to display different things. I'm going to have these to display the current, which gives you an indication of the load on the motor. So I've made this piece up here, this little housing. This is just 3D printed. Just took the measurements, figured it out. And the back here, you've got our controls in, and these are little fill plates that go in the back, like so. And once this gets bolted up to the front of the box, that just holds it all nice and tight in there so that the front panels don't get pushed in. And then we've got a wire channel here. What this uses, we've got flat ribbon wire here, and I've got the connectors in there that plug into these sockets. And I'm probably going to remove this down here and just make one ribbon that replaces this. That's the right length. So they'll be coming over the tops here and out that hole. And we are going to mount this up down here. And let me turn you the right direction here so you can get an idea. Yeah, it's going to set up there something about like that. And when it, you know, the panel will all be vertical, and we should be able to see that from the operator position. Just to have an idea that we're not overloading the motors when we're doing a heavy operation. And I'm probably going, I designed this so I can put an over cover on this because this is not waterproof like this or spray proof. It'll protect it from chips, but you know, if you get coolant on here, it could get inside. So I've got a ridge back here that is designed to take a slip cover that'll drop down from the top and cover this over, and I'll put plexiglass windows in here so you can see these even with the cover on, but it'll come out over the knobs and cover everything over down here. I did it in a way that the cover will be removable, because you use these to program the VFD drives, and there may be times when I want to change a setting in there, or if for some reason I need to run at an alternate speed, I can slow it down using the speed control on here. I don't expect to be using that a lot, but I do want access to it, so if I do a cover at all, it will be removable. So here's a little detail of the back, the way the wiring is going to go. I just fold them over at a right angle on both sides going towards the center, and that will feed through the hole. Slight change of plans here. Originally I was going to have the wires, these leads for the controllers, go over the top of the covers this way and into the hole here, the way the original panel mount was wired through. But I was thinking about this. I got the cover off anyway, so I can access the port, and it makes more sense just to come up through the bottom instead of having that wire over the top kind of in the way, and the cover almost bumps it. So yeah, I wish I had thought of this before I cut the wires, because I probably would have cut them just a little bit longer than I did, but I've got enough here. It does do it. That one will reach up to there, and just lay out along the bottom where all my other connections will be, and I think this will work pretty good. And it should be just a little bit neater on the top. So trying to get this in is a little bit of a balancing act. I have to have it off the hooks down here to get the wires fed in. So I kind of I didn't catch it on camera. Had to kind of balance it on my shoulder, feed the wires through, and then get it hooked on the lower hooks. But got it up there now. I gotta run the back one in, and then I'll be starting to wire this up, and then I got to get the inverters in there, the VFD drives, and the final wiring for them, and then we should be pretty well done in here, and I'll move on to the lower one after that. I'll be covering the wiring and testing of the VFD system in part 2. Thanks for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.